Hi, this is Brittany Lamontagne. I'm the Inside Sales Manager with Burt Process, and I'm very excited to offer this educational experience and to welcome you. And one of the unique positions we have as a distributor is to really take the time that we have on the street with our customers and understand their needs and their desires, everything with our products. And that feedback all goes back to ARO, and they've done something with it. So I'm excited for us to be able to share some of the product innovations that can support your needs and also give some of the detail regarding the process-ready products and the controller. And before I introduce the presenters, there's a lot of people on the webinar today, and that can kind of be difficult with people managing their mute settings. And I'm going to try to leave it open at least for the first several minutes through the introduction, maybe longer. And it might be best to use the controls in your screen, asking questions during the presentation, raising your hand, things of that nature. So we have Ingersoll Rand on the phone, ARO, right now. We have our presenters are Mike Henning and Ken Boyce in product management, and they work on the AODD product lines. And we also have Heather Merton, our DSM for the Northeast. There's just a whole lot of people on this call from Burt Process as well, representing a wealth of knowledge and tenure with this product and our customers. So I think we'll give you a pretty good presentation. We'll learn something, and please let us know if you have any questions. I'm just going to pass this over to you guys, Mike and Ken.
All right, perfect. Thank you very much. I'm happy to be here, and why don't we go ahead and get started. Let's see, there we go. Just a kind of a brief agenda. We're going to be going through ARO process ready, and what that means as far as our pump line is concerned. We're going to go also through the controller. So if I look at, from a history perspective, ARO has a deep history. Just touching on some of the things we've done, we've launched, our Pro Series back in '83, followed up a little bit later with our EXP launch in 2004. We've launched a controller. We were doing a lot of things in the marketplace. Even by the looks of our logo, we've changed quite a bit over the years. And one thing that still kind of holds through all those 88 years of experience is the fact that, we're providing solutions to improve efficiency capabilities for all of our customers. And that's very important. If you look at global, market trends and kind of what's happening in the marketplace, there's three things that kind of ring through if you listen to the experts in the industry. Automated solutions are needed to control and monitor. We need to get away from preventive maintenance and enable or have predictive maintenance in order for us to understand when we need to do that preventive maintenance cycle. And then we also need equipment that operates more efficiently. So if you look at what ARO's done, we have a very reliable product. We offer a 5-year warranty. We've integrated components and controls. We have a controller that integrates directly with our pump, and we've got some controls and aspects that are very important, and we're continuing to evolve those technologies. And then we're also very efficient in our air usage and our motor design, and that's very important when it comes to total cost. If you look at continuous improvement, like I said earlier, we launched a Pro Series. We've got the Compact Series line. We launched EXP a number of years ago. We've got a number of different types of specialty pumps to meet very specific needs in the marketplace. We have an FDA pump and sanitary pump line for customers that need those types of pumps in their application. we've launched the controller. We've launched a long life Teflon or PTFE diaphragm. And also up and coming here is our 3-inch non-metallic pump, which will be launched later this year. So now I'll turn it back to Ken, and he can talk to us a little bit about process ready and what that means in our pump offering.
Yeah, thanks, Mike. When process ready, that's something new, fairly new here with the Ingersoll Rand pumps, or the ARO pumps, with the compact series and the EXP line only. But when you go out and talk to a customer about creating an automated process or monitoring your pump operation, what type of answers do you think they will get?
And unfortunately, I had to mute everyone because because of background noise that were happening. So
all right, okay, Mike,
go through it.
Sorry. Yeah, just hit it. So no problem. So it's going to be reduced effort. You're going to get better precision, better efficiency. You're going to get consistency with your flows and your batching. You can just set it and forget it. You can set it and walk away and know that it's going to be, consistent in its operation and delivery of material. Ease of use, we're going to reduce downtime. We're going to have better control of service intervals by doing predictive maintenance rather than emergency preventative maintenance. So you can plan the maintenance, you can plan the downtime, you can just plan your manufacturing and delivery. And last but not least, you can limit or reduce environmental risk, by monitoring, diaphragm failure or leakage to the environment. So how do we do that? We basically have our process ready or electronic interface pumps that have the end of stroke feedback that you can use to monitor and count cycles for your predictive or preventative maintenance. And you can also validate that the pump has cycled delivering, the material. You have leak detection and then, the solenoid operation where you can precisely control your flow rates, your delivery, and interface with the ARO controller. So, we've been talking a lot about process ready over the last 6 to 9 months. Basically, it's available on all of our EXP and compact standard PD models. It comes with connection points to provide a communication portal, from your pump to a process monitoring and or controller. Basically, the pump is shipped from the factory with leak detection ports in the center body. They're plugged from the factory. We also have the end of stroke sensors. Ports on the EXP, it's an actual port that's around the muffler area that is going to be plugged. And then on the compact series, you basically have to remove the standard muffler and install another muffler with a sensor that goes in and detects the diaphragm rod as it goes back and forth. And then we also have basically solenoid kits where it's a modular solenoid that has the valve body and solenoid all assembled together as a kit. So to convert your product, it's basically removal of 4 to 6 bolts, take the old standard air valve off, put the new solenoid valve on, reattach with those 4 to 6 bolts, and you're up and running. So very easy conversion, from a process ready product once it gets out in the field and you want to convert it. Next, please. So I just went through this, with the end of stroke feedback. You can establish preventative maintenance programs, monitor total number of cycles, provide proof of operational performance. Leak detection, it's a very good accessory to enhance employee safety if you're pumping, some really nasty material that you don't want to be exposed to the environment or exposed to your employees. And then the electronic solenoid control valve, you have complete control of cycle rates and pump flow. Also, as a new feature that's come out recently over the last year is all of our electronic components, that being the end of stroke feedback, leak detection, and solenoid, are all available with hazardous duty ratings for CEC, NEC for North America, or ATEX for worldwide or global applications. Next. So, with the compact and the EXP series pumps, a lot of the facilities are becoming smart facilities or smarter facilities. So, if companies are already in there monitoring and using their pumps with either a PLC or looking for a way to monitor and control, we can use our controller and provide them with a pump that will work right out of the box, turnkey, ready to start working in their environment. Or if you have companies that are not quite yet automation ready, but are going to be in the near future, you can always sell them a pump now with the feature that they can upgrade as needed instead of buying a complete new pump. Next, please. So, now the PD pumps are all shipped from the factory, process ready. Now, we do have, I just want to warn that we possibly might have pumps in stock at the DLC that were built prior to the process ready upgrade. Unfortunately, we did not have a process ready date that on this date all pumps being manufactured were process ready. We phased them in as we used up old components and phased them into the new components. So there's really no drop dead date of knowing that your pump is process ready. The easiest way to verify that your pump is process ready is a visual inspection of looking for the leak detection ports in the center body. That's the easiest way to determine if the pump is process ready. If there are two ports in the air caps that are plugged, that's your leak detection ports. So you're going to have the diaphragm rod internal with a notch in it for the end of stroke sensor. So that's one way of verifying that the pump you received is process ready. Another way to verify it is if the product is not a pre-stock pump, it's a build to order. Every pump now that is being built in Southern Pines and shipped is going to be a process ready pump. So basically we have conversion kits for every compact and EXP pump. The conversion kits consist of end of stroke feedback, both standard and hazardous duty. We have leak detection, both standard and hazardous duty, and we also have solenoid valve kits, both hazardous and standard duty. And we got some pricing down here at the bottom of just our standard non-hazardous duty components. A solenoid is valve body kit, runs about $133 to $369. That's $133 would be on the low end, say a 1/4 inch pump. $369 would be on the high end, that would be the 2-inch pump. End of stroke sensors are $250 to $300. And then the leak detection kit, standard leak detection kit, is a little over $1,000. And those are our list price. We do have them in our EXP catalog, and they are priced and on the system. So if you go out there and look in the price list or go online, everything is released, priced, and active in the system.
Ken, I have a couple comments that are coming in from people. One, yeah, I do want to clarify that while we are still getting through some stock that wasn't process ready, they can be ordered with process ready. So if we know that that's what you want, we can absolutely make sure that's what you're going to get. And then the question that came in, so sometimes people need to use a Pro Series pump and it won't be converted to an EXP. It's just application-wise, it's not possible. Are we able to convert a Pro style pump to a process ready pump, or are there plans to do that?
The current answer is no, we cannot convert a Pro Series pump to a process ready pump. And to my knowledge, short term, there's no plans of doing that. I can't say that long term we might not do it, but as of right now, Pro Series is not process ready or cannot be converted to end-of-stroke feedback, or solenoid actuation, or leak detection. So Pro Series is not available with those options.
Thank you. And people keep sending the questions to me. If you have them, I'm getting them, and we'll get them asked.
Yeah, I don't see any questions on my thing.
Nope. This one came into me via email from my staff.
Okay. Okay. Do you have any more you would like me to address at this time?
I don't see any hands raised. I don't see any questions, and I don't have any others in the email yet. So no,
okay.
We're good.
All right. Thank you. What we have up here on the slide is basically referencing our hazardous duty options. For the NEC, CEC options, and again, that is end-of-stroke, solenoid actuation, and leak detection. We're Class 1 and 2, Div 1 and 2, Group A through D. And then for ATEX, we're Zone 1 and 2, and 21 and 22. Now, our controller is not hazardous duty rated. The controller has a NEMA 4X enclosure. For a hazardous duty environment, if you'd go to the next slide, please, Mike. For a hazardous duty environment, basically, this is an example of how you would set up pumps and a controller in a hazardous duty environment. You'd have to put the controller in a separate room and then do all of your wiring and everything through a barrier or shield wall over to control your pumps in the hazardous area. And then the pump would have all the hazardous duty accessories on it, such as, whatever you want it, the leak detection, solenoid, or whatever. So if you order a pump with hazardous duty components, you're going to have the appropriate barrier devices as part of that pump when you order it from the factory. When you order the kits, or if you look in our catalog, you will notice that you were, like, for a hazardous duty leak detection, you would order 2 hazardous duty sensors and then 1 barrier device separately. They do not come packaged as a kit. But if you order the pump pre-configured with hazardous duty components, you will have your barrier devices and appropriate wiring and connections. So if you go back to the previous slide, Mike, we do have documentation. We've got a little square box there that says confidential on it. That's an engineering document giving us more details of the certifications of hazardous duty ratings for our components. That is posted out on the portal, or if you would like it, please reach out to Heather or myself or Mike, and then we can provide a copy of that as needed.
I got a question. 1 second.
Okay. Sure.
Hold on, I'm pulling up. What is the max speed and flow when using the solenoid valve? They know it's higher than a standard pump, but how much can you improve the speed or flow rate across the family of 1/4 inch to 2 inch and 3 inch?
I'd really have to verify that with engineering, but we're really not going to want to run it past, say, we have 120 PSI max rating, whatever that cycle rate would be. I'd have to check with engineering, but the solenoid is really there for, infinite control and accuracy more than trying to get more out of the pump, or more flow, or you really don't want to operate your pump max capacity because you're just going to wear it out a lot quicker. You would want to upsize that pump to the next size or 2 larger and cycle it at a slower rate so that you get longer intervals between maintenance.
And Kimball, I just unmuted you if you had any follow-up or if that satisfied you.
No, I think that satisfies me, but it's interesting to note that you can run it faster. Like the unit that we tested and played with in our office, you can really speed it up. I know it's not a good idea, but I was wondering, because of that infinite, turn down, what's a good practice? And you've pretty much just outlined it. Don't go above it. So whatever the standard flow rate is, if it's a 1/4 inch pump and it's 5 gallons a minute, don't try and run it at 6 or 7 gallons a minute just because it will actually cycle that fast.
That is very correct, because all you're going to do is the pump is going to fail prematurely, and you're going to have an upset customer that the pump only lasted, weeks or months rather than years.
Understood.
Correct.
Thanks very much.
Hey, thank you. Thanks for the question. So if there's no more questions about the process ready, I'm going to turn it over to Mike for the controller, but I'll just give you guys a few seconds in case there's some additional questions about process ready.
If you have one, if you can raise your hand or on the controller or ask a question here, we'll see it. And if you're in my staff or process, sending the emails working out good too. I don't see any coming up. We can always
yeah, we can always circle around at the end if we need to. Yep. So I'll turn it over to Mike here to go over some controller details now.
Okay, and at the very end, I will go through and unmute everybody.
Okay, that'd be great. Perfect.
All right, perfect. Thank you, Ken. So as we look at the controller, and we're looking at the development of the controller, we talked to customers to try and understand, what were some of those unmet needs that were out there, and what did customers really want when it came to, a control device for their pumps. And what came up was simplicity, the ability to interface with our pumps, modularized turnkey design, some type of out-of-box solution that could be integrated very, very simply with, the leak detection, cycle counter, things like that, having some alarms to detect any type of catastrophic failures. Also, alarms when, batches were finished, things like that. So there was a lot of thought and research that went in when we developed the controller, and we tried to capture as much of that as possible. And now as we go along, we're going to continue to iterate some of those things. And like with the version 2.0 software that I'll talk about a little bit later, we've captured some additional features and introduced those into the software that can be upgraded in the field. So when it came to, the controller opportunity, plug and play, easy to interface with our pump, to try and capture all of those features, having the ability to buy a controller that's pre-wired or not wired. Some people would like to see them not wired and do the wiring themselves. And then the ability to have that function remotely, where you could have a remote button to start a batch, which was important to a lot of customers. And then being able to trigger alarms and then, have complete, types of jobs that you could introduce, whether it be batch filling, proportional control, level sensing, things like that. So, as we looked at that, we developed and then released our controller. And if you look at, from an industry perspective, where the controller is used, it can virtually used anywhere. You just got to look and know, where to look. We know all of these industries have pump opportunities, but we need to look for the controller opportunities. They are there. If you look at water treatment, pH control, and having the ability to inject different chemicals into a fluid based on pH level, batching of ceramic material, having, being able to load different batch sizes, to pull from a larger tank into a smaller tank at the processing level. Metered mixing when it comes to, paints and ink formulation, just to name a few, going from large containers to totes or large containers to buckets, and being able to do that precisely every time. It reduces labor. There's a lot of different opportunities out there. You just got to look for them. If you look at some of these industries, I mentioned some of these a little bit earlier, but there's a lot of opportunity out there. If we look at what's happening in industry and, what they call the IIoT or the Industrial Internet of Things, everything is becoming more automated. And as things become more automated, customers are starting to ask for various pieces of equipment to allow those to be automated so they fit within their process, so they can monitor those pieces of equipment, turn them on and off, making sure they know when they need to perform maintenance on those pieces of equipment based on usage. So our process ready and our controller, brings that to the table and offers that. So applications are truly everywhere. When you talk about repackaging, remote access, dosing, monitoring, precision metering, just to name a few, all those processes are out there. To illustrate that, if you look at the pictures on the bottom, there's a application where we're controlling pH for laundry water reuse system. We've got an additive control for wastewater treatment. We're doing batch control with our controller in a ceramic manufacturing material production area. So there's a lot of applications out there where people, or maybe it's a labor intensive, where they're having to have a person stand by while a pump's running, filling a tote or running a batch, so they have to turn it off manually. This gives them the ability to remotely turn things on and off, monitor, process as far as where it is in the process, and then even get alarms then when batches are finished with the new software. So if you look at this particular case at the bottom, our EXP pump, with the solenoid air valve, some sensors as far as on a tank, in a batch, we were able to implement using, into a situation where a customer was filling totes off of a larger tank. So, there's a lot of applications out there. People are dispensing out of totes in the automotive industry and the trucking industry every day, and it's a perfect application for a metering, with a controller off of that tote, to get a precise amount of whether it's coolant or DEF or things of that nature out of that tote and into a vehicle or into another container as they move that product around their facilities. Here's another application where we're controlling water quality for steam generation. There's a couple of ARO pumps, a dual pump controller. The advantage was, our system was plug and play. We're able to pre-program the controller for the dosage control. The pumps are operated remotely by the controller. And then, what value does that add for the customer? For this particular customer, it saved 250 man hours a year in labor, which is an estimate. We decreased operational costs by over $7,000 a year. And there was also a decrease in the amount of additive being used by 6% because they could more precisely measure the additive being added to the water, prior to steam generation. So there's applications out there like that where, you can save labor hours by not having a person stand around or running back and forth monitoring a pump while it's doing something. You can save customers money by being able to accurately measure and put an additive into a system or put product into a batch. So there's all kinds of opportunities out there like this. We got a couple of case studies out there on the website. I encourage all of you to download those, read through them. There's a couple of good applications out there where a controller has been introduced. We also have a white paper out there on our controller. Very important. You can read that, learn a little bit more about the controller, And we'll continue to add case studies as they become available and get those out on the portal so you can take a look at those, read those, and maybe those will spur ideas for you as you're out in the field looking for new opportunities. There's a new software update that's available for our controller that is out in the field today. If you look at what's available, we listen to our customers. They're asking for one, increased batch capability. So instead of 2 batches or being able to have 2 batches per pump, you can now have 5 batches per pump with the latest software. They also wanted the ability to more accurately control the amount of material maybe going into a batch or being introduced into a flow stream. So we've introduced a flow meter option, and you can now configure a flow meter setup with the controller as well. There's a need for alarm on end of batch, so now that is available. And you can also synchronize 2 pumps off of a controller where they're running simultaneously with different ratios. You know, if you wanted a 1-to-1 mix or a 2-to-1 mix from 2 different vats into a batching vat, you can do that now. So that's available in the latest upgrade of the software, the 2.0 software. We've also created an updated or cleaned up menu structure, so it's a little bit easier to navigate. Again, if we look within that menu structure, we've added some different ways to calibrate using different types of units. There's some introduction of different units there. The flow meter setup, the alarm setup on end of batch, and then the 5 different batches, A through E for each pump. So when we talk about flow meter, we done some lab work on our own here before we introduce this, because there's this question of what does it do for you? Does it increase accuracy? And the short answer is yes. So if you look at the setup on the left, we've got a PE pump. You know, we're monitoring in a stroke, we're discharging product, and our accuracy measurements are down there below, anywhere from 8 to 3%, depending on batch size with a 1/4-inch pump. If you look at the setup on the right, we're using a flow meter, solenoid actuated valve, and because you're not waiting for that full stroke in the pump, you know, emptying out both diaphragms, you're able to precisely, you know, depending on the accuracy of your flow meter, you can precisely turn off that solenoid valve mid-stroke on the pump. So you can get a very accurate or a much more accurate volume when it comes to this type of a setup. Now this is a specific setup with a 1/4-inch pump. Other applications could vary, and it depends on the accuracy of your pump or accuracy of your flow meter rather. And then, you know, from a flow meter perspective, the flow meter needs to meet some specific criteria as well. It needs to be operating 0 to 24 volts DC, maximum 500 pulses per second. So if you've got an application where you want to introduce a flow meter and a solenoid valve, I would encourage you to call our tech services team, you know, find out about, you know, the limitations that we need to see as far as the flow meter is concerned, and they can help you with any type of setup that you may need in the field. Now, a couple things to note with this flow meter setup. The ARO controller controls a solenoid valve used with the flow meter to regulate flow, not the pump. So in that particular situation, you're not using a PE pump or an electronic interface pump, you're using just a PD pump. When you're using 2 PE pumps or 2 flow meters, they can be used at the same time and controlled with the controller at the same time. So it's important, 2 EI pumps or 2 flow meter setups. You can have in a controller that is set up for 2 pump situations, you can have a PE pump set up on one of the cables, you can have a flow meter set up on the other, but you can't operate them at the same time with the controller. They can be, one can be turned on, turned off, and then the other one can be turned on and then turned off. It's just a limitation in the way the software with the calibration and the coding in the software works. So that is just one limitation within the software. And pumps can interface with the controller. There's anything with any pump with an electronic interface can interact with our controller as we move forward. If you look at controller software, the version 2.0, like I said, is available. It is out on our portal. I'm going to try and click in. Oops. If you get into the downloads area, you'll get into a screen that looks like this with the controller. You click on downloads, you click on manuals and software, and then you scroll down and you'll find a download area for the software and a download area for the new version of the manual. Now in the manual, there are explicit instructions on how to upgrade to the latest software. It's in section 4 of the manual. You do need this cable, which is a USB type B to type A. People that look at that, it looks like it's a printer cable. That's what a printer cable is. It's type B to type A. And you need to be able to have access to the controller because you have to open up the controller and interface with the circuit board in the back. So that's important as well. So if you have somebody that has a controller today, they want 5 batch capability, or they need better accuracy and they want to introduce a flow meter, then they'll need to upgrade to the new software. So like we mentioned earlier, if you look at, the way everything kind of comes together, we've got our controller, we've got end of stroke feedback, we've got electronic solenoid control valves, we've got leak detection. We've got them both in regular duty and hazardous duty. We can help minimize downtime and allow for better control of a process with these functions on the EXP pumps as well as with our controller. And that, accuracy of the flow meter, also helps enhance batch accuracy out in the field. These are the 3 different part numbers from a configuration standpoint that the controller is available in. There's a controller available without cabling, one with a single cable that has the interfaces that work with the features that would come on a EXP process-ready pump. And also, there's one version with 2 cables if you need to control 2 pumps in the field at the same time, or you want to have that availability in the field. Like Ken mentioned earlier, we've got a lot of different end-of-stroke sensors, one for both regular duty, hazardous duty ATEX, and they're also certified for NEC and CEC as well. If we look at all the different sizes are available, and for end-of-stroke, it is a little bit different on the compact series. You need to remove the muffler assembly in order to introduce the end-of-stroke sensor. Leak detection, again, both available in regular duty, heavy duty, in all of our pump sizes. And then solenoid valve blocks. This comes as a unit. We're showing it exploded here, but it comes as a single unit that can be easily added onto a pump. It's a 4 or 6 bolts that hold that particular unit on. And it's available in a variety of different materials, aluminum, stainless steel, as well as polypropylene and then also in a variety of different voltages, depending on what your needs are. Also with, hazardous duty or regular duty certifications. So, as I mentioned earlier, the controller is available. It mates up seamlessly with our electronic interface pumps. And it allows users to program a variety of batch setups that are very repeatable from a dispensing standpoint, which means fewer messes, more accurate batch transfers, less labor. That's the biggest one. That's where a lot of savings can be seen, is just in labor savings. You can also remote access your pumps. So if you do have a hazardous environment, or you're transferring acid and there's fumes that you don't want your operators exposed to, they can remotely actuate pumps for those type of transfers or batching applications. And then we've got the ability to alert you as soon as that batch is complete via an alarm or some type of signal to the operator that the batch is complete.
So we do have a couple questions that have come up.
Okay.
And I will probably open it up so that people can ask questions about this. And then I know we have a little bit of a kind of a sneak preview of the 3-inch non-metallic pump that's coming up that we can go back to after. One question is there a 3-pack available for the kits, the conversion kits or the connection kits? I know there's 3 different kits, but
oh, you mean combining the solenoid with the leak detection with the end of stroke?
Correct.
No, there is not. You'd have to order them all individually.
Okay, and is that just because that people don't need all of them typically?
Yeah, typically, you do not need all of them, plus the variations of especially solenoid kits when you have different materials of construction, aluminum, poly, stainless steel, and then all the various solenoid actuations. It would just be very difficult to to have all those kits available as, one. So at this time, you just order each individual kit.
Okay, the next question is, what's the max distance a controller can be from a pump if they're using a barrier?
I think right now we have available 50 feet of cable that will run from the pump to the controller available.
Okay. And the next question was, can the flow meter work with an existing non-ARO controller that a customer might have existing?
Will a flow meter work with a non-ARO controller?
Can the flow... And Mike, I just unmuted you if you wanted, Mike Colillo, if you wanted to elaborate with your question a little bit.
Yeah, can you hear me okay?
Yes.
Yes.
Okay, I'm getting feedback, but I have a customer who's looking for to batch using a controller to batch. He's got an existing controller. I'm wondering if hard to get a flow meter with a diaphragm pump. Will your pump send a signal to an existing controller that they already have to batch?
If it depends on the controller and what types of signals it'll take in. If it's just a standard PLC type controller, yes, or our pumps would interface with that. But we just need to get more details and talk about it. So if you can get more detail on that and get that into our tech service group, we can help you out with that.
Well, Mike, remember with this flow meter, if you remember, if you can go back to that slide, Mike, with the flow meter, the controller is not controlling the pump. The controller is controlling a valve off and on
Right.
from the flow meter.
But I think the question was, from a batching perspective, can a different type of controller control a valve and a flow meter and take a sensor input off the flow meter? Possibly. It just depends on what type of controller you're talking about. So again, let's get that information into our tech services group, and we'll see what we can do to help you out.
Thank you.
I'm going through and I'm unmuting everyone. Normally I'm used to using GoToWebinar. I apologize. I haven't found the one to undo everyone all at once. But most of you should be able to ask questions if you have any right now. No question, getting lots of feedback now. All right, I'm going to mute them back if no one has any right now just because of the feedback. So if anyone has any, just raise your hand and we'll make sure I'll unmute you and we'll get to your question. Oh, Kimball's got a hand raised. Go ahead, Kimball.
Thanks, Brittany. I had a question on the flow meter slide. The flow meter is not an Ingersoll Rand product. That's someone else's product. Am I right about that?
You are correct.
So you don't really have any Go ahead.
Yeah, we don't currently make a flow meter. We have used in our lab and have some experience with gear-driven flow meters. They seem to be a little bit more accurate, but we can help you with maybe a recommendation on things that we've used from a lab perspective. But there's a variety of different flow meters out there, and there's some parameters that flow meter needs to operate within. Like I said, 0 to 24 volts DC, as well as the pulsation coming off that flow meter needs to be less than 500 pulses per second in order for our controller to read those pulses. And those pulses correspond with volume going through the flow meter. So many pulses per gallon, so or per unit of measure. So the answer is no, we don't make flow meters. It wasn't our flow meter, but we could help maybe guide you to a proper flow meter through our tech services group.
Okay, great. Thank you.
Okay, and let me unmute you last if you got a question. Okay, Les, I unmuted you.
Oh, thank you. Okay, getting back to the barrier and the length from the barrier device to the controller, you say you have a cable that's 50 foot max, correct? Is that what you're saying earlier?
Yes, cable from the controller, that we supply to the pump is, yes, 50 feet max that we have.
Okay,
okay, go ahead.
So my question is it possible that an extended cable could be made to extend that out? And if so, what would be the distance? I'm just saying if that controller has to be further away based on the wall and where the proximity of that controller can be.
I would refer to the electrician that's doing the installation. He might have to do an amplification or something of the signals, but for us, it's 50 feet. Not saying that it could be long, but a qualified electrician would have to verify that.
And I'll follow up.
Is there a loss of the signal? Is that what we're saying?
Excuse me?
Is there going to be a loss of the signal due to the length?
We would have to ask a qualified engineer or electrician to answer that. I really don't know, to be honest with you.
Yeah, Brittany, I'll take that question. Brittany, I'll take that question offline with our controller engineer who will be back on Monday, and we'll get you an answer.
I'll hook you up with Lass.
Okay, perfect.
Great.
Thank you.
Thank you. Any other questions before we go into the 3-inch pump? I've been waiting for 14 years for a 3-inch metallic pump. I'm all excited. All right, go for it.
All right. Well, I'll turn it back over to Ken for this portion of the presentation. But I apologize for the raspiness of my voice here. I just moved to North Carolina, and the pollen is driving me crazy. So it's that time of year down here.
That would be pine pollen. It's everything has got a coating of yellowish green right now. It's crazy.
Yeah.
Up in New Hampshire, we have a coating of white right now because it's snowing.
No. I'd rather have the green than the white.
I'd rather be sniffling.
Yeah, there you go. I just would like to touch briefly and give you a sneak preview of a 3-inch non-metallic pump that we are currently under development and have a plan of launching late August, early September. So I just wanted to, touch briefly on it. Mike, if you go to the next slide. We've had some customer unmet needs and some concerns that, ARO needs to be able to offer a quicker transfer to unload, trucks, tanker trucks, and a more affordable pump than our metallic options currently. So, there are competitors out there that do have a 3-inch non-metallic that we have not been able to compete with. So we're developing this product. We're well through the project. Things have been going very well, and target release right now is middle to end of August. We'll have a big launch, a big splash, and we'll let everybody know in plenty of time what's going on there. Next slide, please. So basically, our 3-inch non-metallic is going to have a 47% higher flow rate than our ARO 2-inch non-metallic. The 2-inch non-metallic is like 184 GPM. Our new 3-inch is going to be 270 GPM. At 120 PSI. We're going to be in polypropylene and or PVDF with, a lot of different ball and diaphragm materials, including our long life PTFE, nitrile, high trial, and Santoprene. So this pump will be shipped process ready. You will be able to hook up solenoid actuation, leak detection, and end of stroke. So you can order it from the factory pre-assembled as a PE pump, or it will be shipped from the factory process ready, and we'll have the kits available to convert it in the field. So what we've done here is we've basically taken 3 different GPM deliveries, 20 GPM at 100 PSI, 90 GPM at 40 PSI, and then 150 GPM at 20 PSI. And then down the left-hand side here, we have it running various hours of the day, 4 hours a day minimum up to 24 hours a day. And we did a total cost of ownership calculation to see where the 3-inch, would fit into certain applications over a 2-inch. So basically anything in green is where a 3-inch is going to be more cost effective than a 2-inch. And as you can see, the low GPM, 20 GPM, it really warrants a 2-inch, 99% of the time. But as you get into higher GPM delivery and longer operations during the day, that's where the 3-inch is really going to shine. So over here on the right-hand side of the slide, you can see the 2-inch is about half the price, roughly 45 to 50% or half the price of a 3-inch pump. And that is figured into the calculations here. So the calculations that we did were, basically based on 300 days of a year of operation and services of one every 1.5 million cycles. And then we threw in just a service labor rate of $50 an hour. So we came up with this chart here. So this is just kind of an easy glance or an easy eye chart to look at to say, hey, you know, if I got a customer that's currently using a 2-inch pump and he's trying to deliver 90 GPM and he's running it 24 hours a day, it's very easy to show him here that a 3-inch pump is the way to go, and we'll give him better total cost of ownership over the 2-inch pump he's currently using. So, and here's the same chart, but without any dollar figures in there, to just kind of give a quick glance of where you would want to zero in on a 3-inch non-metallic model. Next slide, please. So what we've done here during our development is we've taken 2 key competitors, and we went through that same scenario of 4 hours a day of intermittent use, 300 days a year, and repairing the pump every 1.5 million cycles. And as you can see, in 1 year, we have a very big advantage of total cost of ownership over 2 leading competitors. You know, ours comes in, and this is all at list price, and this includes the upfront cost of the pump. But, you know, as you can see, we're under $20,000 a year, where our nearest competitor comes in at over $28,000 a year. And we are currently have 2 more competitors that we're doing the same thing on. So at the launch of the new 3-inch non-metallic pump, we're going to have 4 total cost of ownership or street fighter calculations against our 4 major competitors versus our product. We'll go in a little more detail than this quick chart here. So stay tuned for some good ammunition and some good marketing collateral to go out and attack competitive installed bases with 3-inch non-metallic models. Next, please. So, you know, some of our, you know, not only for the 3-inch non-metallic, but for, you know, the ARO line itself, differentiation and competitive advantages, you know, total cost of ownership, not only for our 3-inch non-metallic, we've done similar things for our 2-inch metallic models and some various other sizes and materials of construction. And we're basically, you know, total cost of ownership leader. You know, fewer annual repairs, less downtime. We have a wide range of operating conditions. Electronic interface capability, you know, and process ready, that's really big. Some of our competitors do have leak detection, but it's only with the 2-piece PTFE diaphragms. Some of our competitors do have electronic interface, but they don't have the full gamut that we have of end-of-stroke, solenoid actuation, and leak detection. And of course, the 3-inch non-metallic, you know, it has used the EXP air motor design, you know, that's proven ice-free operation, unstallable air valve, and just a very reliable product. So I believe that's it on the 3-inch non-metallic. Again, stay tuned. We're going to be having a big launch and, you know, let everybody know what's going on sometime in August.
Excellent. Thank you both so much. I really appreciate the time. We are right at 4 o'clock. That's exciting as well. I haven't seen any other questions come up, but if anyone has any, I am going to send out a follow-up to this, and I did record this webinar, so I'll make it available for people. So you'll have my information. You'll be able to reach out with any questions, and we'll get right back to you. Thank you, everyone. I hope you have a wonderful weekend.
All right. Thanks, everyone. Appreciate it.
Yep. Thanks, everyone.
Have a good weekend. Thanks, Brittany. Thanks, Heather.